Okay, let's go through the 4.4 to 4.6 review. The first question is graphing a line that's already in slope-intercept form. You do need to use your mouse for this, not your fingers. It works better on your mouse using a mouse. It also works better if you are in Google Chrome. So this is kind of a weird glitch. Right now, I click line A to put something on the graph, and it puts 2 dots. And if I move those 2 dots, I don't know why it wasn't showing the line originally, but whatever. So you get you click the button to get something on the graph, and then you move one of the points to the y-intercept -1, and you move the other point to make a slope of 3. So from the first point, from the y-intercept, up 3, right 1. And that is how you graph something that's already in slope-intercept form. The second one is not yet in slope-intercept form, so we need to do a little bit of work. We've got 3x plus 2y equals 8. We are going to subtract 3x on both sides. So we get 2y equals -3x plus 8. And then divide everything by 2. So the equation that we're actually graphing is -3/2 x plus 4. And then it's just like that first problem. So you click line B to put something on the graph. Drag 1 dot to your y-intercept of 4. It does not matter which dot you drag there, as long as you drag one of the dots there. And then -3/2 means down 3, right 2. Okay, -3/2 x plus 4. Match each line to its slope. First thing I notice is that line 4 is this line that appears to have negative slope. So I know line 4 is negative. So you grab line 4 and drag it until it highlights the slope that you want, and that links those two together. So line 4 has a slope of -2. Line 2 is a horizontal line that's 0. So line 2 matches with 0. And this second column will be randomized. So yours may not be lined up exactly the same as mine. Line 1, from this point 0, 0, it looks like 1, 2, 3. It goes up like 4. Oh, shoot. It goes up 2 and then over 1. So it looks like line 1 has a slope of 2, which means line 3 would have a slope of 2/5. And notice 2/5 would take this off the graph. So there isn't really even a point that we can start at here. And it definitely looks like it maybe starts down here at 0, -1, and goes up 1, 2, and then over, well, it's the only one left. It matches with 2/5. I don't like this picture. I think the picture on your test is much better than this picture. It's got more detail than this picture does. Uh-oh. Don't know what was going on there, but it's back. Here's question 4. Determine whether the lines passing through the pairs of points are parallel, perpendicular, or neither. And notice I did put the slope formula up above for you. So we need to find the slope of each line. So the slope of the first one, of line 1, we would do 2 minus 3 on the top and 0 minus a -5 on the bottom. That's -1 over 5. Line 2, we would do 9 minus 7 on the top, 1 minus 11 on the bottom. That's 2 over -10, which simplifies to -1/5. They are both -1/5. That makes them parallel. The next one is similar, but this time it has the equations instead of the points. So I need to take the first one and subtract 4x on both sides. That would give me -6y equals -4x plus 30. Divide everything by -6. And we could write out what the entire equation is, but quite frankly, we don't care. All we really care about is this part right here. -4 over 6 simplifies to 2/3. So the slope of that first one is 2/3. Then I start working on the second one. I want to keep the 2y on this side. I want to subtract 3x on both sides. Divide everything by 2. And again, I just care about this. That's negative 3/2. So 2/3 and negative 3/2, those are opposite reciprocals of each other. So those are perpendicular. Write the equation of the line that passes through the point and has the slope. So the formulas are all there for you. We do y minus the y value of the point equals the slope times x minus the x value of the point. Minus the negative is plus, and actually this minus the negative here is also a plus. Distribute, we've got 3x plus 15. Subtract 4 on both sides, we get y equals 3x plus, 15 minus 4 is 11, not 9. So y equals 3x plus 11, and that one is multiple choice. Now notice you can automatically, since you know the slope is 3, you can say, I know it's not that one. The other thing that you could do is you could take each of these options and plug -5 into the x and see which one gives you an answer of -4. So that's another way that you could do that problem. This one, however, that method's not going to help you because you do have to truly write it all out yourself. So your first step is to find your slope. So we would do 7 minus 3 over -4 minus a -5. That gives us 4 over 1, so our slope is 4. Then we pick a point. It really doesn't matter which point you use. Both of them have a negative, so I'm just going to use the first one. So y minus 3 equals 4 times x minus a -5. Minus the negative really means plus. So I've got 4x plus 20. Add 3 on both sides. And we get y equals 4x plus 23. Now, this particular problem, it says, write the equation in slope-intercept form that passes through the points. You have to make sure on this problem that you type in y equals 4x plus 23. The biggest mistakes that I see are that people forget the y equals, or they type in y equals 4 plus 23. You have to have an x there. So don't forget your y equals and don't forget your x. Make sure both of those pieces get in there. So you need to write the full equation in slope-intercept form. I may even on the test put a little note here, don't forget to type in y equals and your x. I may not get to that, but remember on this problem, there is no y equals there. You have to type in the full equation. Otherwise, you're not getting this problem correct. This problem has also been set up so that if you type in this in point slope form, it will count it wrong. So even if you type in y minus 3 equals 4 times x plus 5, it will count your answer wrong. You must put this in slope-intercept form in order to get your answer correct. This one we went over on Wednesday. Notice these 2 points have something in common. They both have a y value of 3. That means y equals 3. Your answer choices should kind of give you a hint that something weird is going on here. If you actually found the slope, you would do 3 minus 3 over -1 minus 4 and get 0 over -5, which is a slope of 0, which means it's a horizontal line. If it's a horizontal line, the equation is y equals, what is the y value? The y value is 3. So that's the full way to do this problem. But what I want you to notice, just, strategic laziness, just being quick, when you look at these 2 points, they both have a y value of 3. So the only equation that would go through both of these points is y equals 3. All right, write the equation in slope-intercept form of the line described. So what I notice here is that this equation x plus 3y equals 12 is the same on both of them, and one of them's parallel, one of them's perpendicular. So the first thing I'm going to do is take this x plus 3y equals 12 and get that rearranged to help me out. So 3y equals -x plus 12, divide everything by 3, and I notice that this problem has an original slope of -1/3. All right, so that's the slope that we're going to use. So for parallel, we're going to use the slope -1/3. Parallel means same slope. So y minus 6 equals -1/3 times x minus a -3. There we go. Minus the negative means plus. Let's distribute. We've got, oops, I don't want blue. Y minus 6 equals -1/3 x. -1/3 times 3 is -1. Add 6 on both sides. -1/3 x plus 5. And this time it's just filling in the blanks. And you're going to type this in. There's no math keyboard. So -1 divided by 3. So use the slash. Use the division button on your keyboard. -1/3. -1 divided by 3. The x is already there. And then you type in the 5. Next, we want to do one that is perpendicular. Perpendicular to -1/3 is +3. So y minus 6 equals 3 times x minus a -3. That's actually a plus. Y minus 6 equals 3x plus 9. Add 6 on both sides. Y equals 3x plus 15. Notice the x is there, so 3x plus 15. Be very, very careful on this test to look at your answer, where you put your answer in, to make sure, do I need to type an x in or do I not need to type an x in? If you're filling in the blanks, you won't have to type in the x. If you are typing the whole equation, you need to type the x. Okay. Next up, we are graphing linear inequalities. Ooh, I'm sorry, I need to take that out of there. This is kind of hard to see, isn't it? Okay, so we're graphing the inequality y minus 4x is greater than 2. We need to add 4x on both sides, which does not change anything, so we have 4x plus 2. So first we click line A, and we graph this just like we did the line. So start with one dot on 2. The other dot we need to make a slope of 4, so 1, 2, 3, 4 over 1. Then we click solution set. Oops, we've missed something. Still on line A, we have to decide, do we want this to be a dashed line or a solid line? Since this is plain greater than, we want a dashed line. Then we click solution set and we decide where to shade. Our final symbol was greater than, which means we shade up. So you click that side up and that's where the final solution set is. Remember, if the whole up or down is confusing, we could plug in 0, 0. See if 0, 0 makes a true statement or a false statement. If it makes a true statement, you shade that side. This one, it would make a false statement, so we would shade the other side. Okay, x minus 2y is greater than or equal to 10. We need to subtract x on both sides. And then divide everything by -2. When we divide everything by -2, it flips that sign. So y is less than or equal to +1/2 x minus 5. We click line A, and I'm going to tell you right now, it needs to be solid. Put one of our dots at -5. Ooh, be careful here. That -6 looks an awful lot like 5. I probably need to change this scale a little bit. I may consider changing the scale so that doesn't show, but be very careful. That actually is a -6. Make sure you count. And then a slope of 1/2, that'd be up 1, right 2. And then it's now less than, so I would need to click and shade below. The next one is a horizontal line. We click line A. I might have to scroll over here. We need this to be a horizontal line at 4. So it doesn't matter where the dots go as long as you create a horizontal line. Whoops, it says -4. We should probably make sure it's at -4. This should be a dashed line, and it says greater than, so we click solution set and shade up. This one, x plus 3 is greater than or equal to 4. We subtract 3 on both sides. Click line A. We want a vertical line. It does need to be solid at 1, so make your dots be vertical. And then it needs to be greater than 1, so we shade to the right. Let me know if you need any help with any of these, but that is it for our test.